Okay, 46. Same as I told you before. Make sure you identify what are they asking about and what are they giving you. So they're giving us a graph of f prime, but they're asking where f has a relative maximum. Here's another one where people have been very sad. They answer the question, they feel like they understood everything perfectly, they get the wrong answer, they're trying to figure out why, and when they come and ask me, as we talk about it, I find out that they went and found the relative minimum. So go careful. Go careful. Where does f have a relative minimum? So hands up, who knows? Feel free to use your reference sheet. Where does f have a relative minimum? We'll just wait. Oh, now I'm doing it. Relative maximum. Thank you. Relative maximum. So where does f have a relative maximum? At what x coordinate? Just keep waiting. You can put your hand down for a second. Let people think for a second. I feel like a few people know. Raise your hand if you feel like you know. Show me. We're about 80% of the class. Hands down again. Did I give you the practice test? Okay, hands up, who knows? Show me. Most, not everybody yet, but most. Let's go, Samuel.
Would it be -1?
So Samuel goes to x equal -1. And at x equal -1, here's what's happening. Let me type it again so it's a little more clear than my handwriting. 2 points if you had your hand raised. Here's what we have. I'm going to call on somebody to help me here in a second. So we would say, so Samuel's contention is that f of x has a relative max at x equal -1. So what would be the reason, Samuel, that you would be saying that f has a relative max at that x coordinate?
Because there's the peak right there.
So you'd be saying, and we're looking at a graph of what? Samuel?
Say one more time.
So we're looking at a graph of what?
F prime.
Good. So you'd be saying f of x has a relative max at x equal -1 because f prime changes, increase to decrease, hence the peak, at x equal -1. So 2 more points for Samuel for a total of 4. But he is making a mistake. It doesn't matter. Mistakes, we don't care about mistakes as long as we figure them out. Who knows what the error is? Hands up. Like, that is wrong. This statement is false. You can't say that. So what's wrong with that statement? So 2 points if your hand is raised. Let's go to Stephanie.
The graph is f prime, but you're looking at the relative max is when it changes from increase to decrease, but like on f prime, it's changing from increase to decrease, but that's not the graph of f.
So let's fix this. So Stephanie, how can I fix, so this green statement is wrong, but I can make a small change to this green statement and the green statement becomes correct. Let's go 2 for Stephanie. Who knows how to change the green statement, everybody, so that it becomes a correct statement? Let's go, Kate.
F of x has a relative max at x equals 4 because that's when the slope changes from positive to negative.
Let's go write that down. So we say
Slope of f prime.
over here, change color, f of x has a relative max at x equal what, Kate?
4.
4, because, come on, And what's the because on this one, Kate?
Because the slope of f prime of x changes from, oh no, the graph of f prime of x changes from positive to negative. Which means that the slope of f of x would be changing from positive to negative as well.
The key thing, two more for Caden, that you've got to do is what he did. You're being tested on your ability to know how one thing affects another and how they vary. So Caden is right. The relative max on f will occur at x equal 4. We don't see that on this graph, but we have to interpret the meaning to figure that out. So f has a relative max at x equal 4 because f prime changes from positive to negative there, yes, which means the slope of f changes from positive to negative at x equal 4, which means, kind of a long thing, f of x itself changes from increase to decrease at x equal 4. So the brown statement is correct. I could fix the green statement. One second, Josh. I'm sorry. I could fix the green statement. Go ahead, you go first, Sasha, sorry.
Couldn't you fix it by saying instead of R max, isn't it R min? Like, isn't it the minimum?
At x equal,
-1
our minimum of what?
of f of x.
Of f of x. So it's not. Let me help you see why. Like, you tell me why you thought it was so I can help you fix your error.
Because that's where like the peak of the change, the rate of changes.
Oh, that's interesting. Let's go compare that one second. Two more for Sasha. Okay, the green statement is false. I'm going to fix the green statement before I go away from my keyboard. Julie, please.
Could you take away the prime of f prime of x? Just take away the prime and then it will be correct?
No, because f isn't changing increase to decrease at that point. Two more though, please.
Could you add a prime to f of x at the beginning?
That I can't do. Now it's true. If we're looking at f prime, we can see this is a relative max on f prime. This is another relative max on f prime. This is a relative min on f prime because we're looking at f prime. Two more for Evelyn. And then I was going to go do Sasha's thing. One second.
I think I just need to watch the videos because I went like in last class.
Oh, hang with it for a minute. You're okay. Your question is spot on for this, Sasha, so don't stress too much. Let's go back to the reference sheet. I think is the best place to hopefully point out what you're kind of where you were tripping up just a little bit. 45 pages earlier. Close. So what we are doing on problem 40, which one are we on? 48?
46.
46. What we're doing on problem 46 is we are looking at f prime, but we're trying to figure out where the unseen graph of f has a relative max. So the definition is this is a relative max on f right there. F goes up, f goes back down, relative max. But we have to figure that out by looking at f prime. So Danica's chart shows us the correspondence. When f is doing this, every value of f prime will be positive. So if we come over to f prime, we notice that through here, every value of f prime is positive. So whenever f prime is positive, look at f. F is strictly going up. Because f prime is the slope of f. It's the rate of change of f. And the only way f can go up is if the rate of change is positive. So these positive values of f prime tell me f must be going up. But then right here, those values of f prime change. They are no longer positive. Now they are negative. Whenever those values of f prime are negative, all of these, the values of f have to go down. So that's why we see F going down through all of this region. Because the rate of change of F, which is indicated by F prime, is negative. So that's why we know that's the relative max of F, but we found it by studying the values of F prime. Cal, please.
Why would it not be like on 46, -2? Would that be like the minimum?
Let's go back over there real quick. Hold on.
Past it.
Ah, too far. Almost. Say it one more time, Cal.
Why would it not be at like, because it's changing from negative to positive at -2? Would that be like the minimum, or how do you know like which one it is?
I'm going to type it. You're on the right track. I just want to spell it out so there's no confusion. So at x equal -2, you are looking at the graph of F prime. So you tell me, Cal, as I get ready to type here, what is the graph of F prime doing at precisely x equal -2?
It's going from negative to positive.
Perfect. So you type F prime of x changes negative to positive at x equal -2. And then you write, therefore, f of x changes in what way, Cal, at x equal -2? Yeah, go ahead and look, you're fine.
Negative to positive.
So not correct
Or
on that
will
one.
it switch?
So look at Danica's chart. So look at the chart on your reference sheet in the top left. I'm going to drag it out here so it shows up on the video. You just said correctly. Okay, remember, each column is only talking about y coordinates. So f prime, you are correct, at x equal -2 is changing from negative y values to positive y values. Danica's chart reminds us that that means the values of f will change from going down to going up. So at this point, x equal -2, the values of f are going down, but then they change to going up. So that's what we type up here. So f of x changes from decrease to increase at x equal -2. A lot of therefores. Therefore, f of x has a relative min at x equal -2. I can't really tell if that helped out.
Yeah, it's the minimum because it's changing from decrease to increase.
It's the relative min on f, because f is changing decrease to increase at x equal -2, yes.
Okay.
And we are finding it by looking at f prime.
Okay. Yeah.
Cheyenne, please. I'll do it.
And then for just like x equals 1, that just like doesn't really factor into like our interest because it doesn't cross the x-axis.
Sorry, I got distracted at the door. One more time.
No, you're good. So at x equals 1, that's not a relative minimum or relative maximum because it doesn't cross the x-axis.
Perfect.
Okay.
Okay, look, look, let me draw it. Prior to x equal 1, two more for Cheyenne, f prime is positive. When f prime is positive, that means f itself is going up, because f has a positive rate of change. So if I were trying to sketch f, I would show f rising. But these values are getting less and less, so that means the slope of f is getting less and less. So f's doing something like this. It's going up, but its slope of f is getting less and less. Right here at x equal 1, the slope of f is 0. So I've drawn a slope of 0. Then the slope continues to be positive and then more positive. So f does something like that. That's kind of what f is doing around x equal 1. So that's
Okay.
not a relative min or a relative max. So. Question? Please do it.
So does every time anything, whether it's prime or not, across the x-axis, there'll be a relative max or minimum?
You couldn't say that. You could say this, looking at Danica's chart, that if f prime crosses the horizontal axis, F will have a relative min or max. If F double prime crosses the horizontal axis, F prime will have a relative min or max. But that would mean that F itself was having an inflection point. Two more. Okay, so back to 46. Clear this off so we can kind of summarize quickly. So the correct answer is the relative max of F is going to occur at x equal 4, because that's where F prime is changing positive to negative, which means that is where F would be changing from increase to decrease. Please go.
Why is -3 not considered in the what do they call it? The relative maximum? Because it's also changing.
So,
-3, not 3.
oh, -3. Over here.
Yeah.
Oh, gotcha. Because based on the graph, we can't tell for sure whether this change continues.
Because
It could do this.
Yeah.
Plus, again, that wouldn't be a relative anything on F. It would only be a relative something on F prime.
Okay.
So the reason I have this on the board is I'm going to just keep forcing all of you to say this word. You can never say the word relative min, relative max, or inflection point, or relative extrema without using this with that word. Because you have to say relative min of. Otherwise, the sentence will make no sense. Yeah, Julia, please.
In both of your explanations, this is the one on the left, the y values are the ones changing from positive to negative. Oh, just kidding.
You're good. Two more. Anybody else? Cool. Stop this video.